Hello friends, welcome to EC Academy. Today we are going to talk about something that is very important, the silicon wafer. We can say the silicon wafer is the heart of electronics. Now this silicon wafer is the base material for semiconductor manufacturing. So the silicon wafer is very important in electronics. So this silicon wafer is the base material that is used in semiconductor manufacturing. So in today's lecture, we'll understand the wafer processing. So what is silicon wafer? First, let us understand the basics. A silicon wafer is a very thin disc that is made up of single crystal silicon. So silicon wafer is a thin disc that is made up of single crystal silicon. You can just imagine a CD or DVD, but this silicon crystal is much smaller and it is made up of pure silicon. Typically, these wafers are between 75 millimeter to 150 millimeter in diameter and are extremely thin, which means they are less than 1 millimeter thick. So this is the thin layer where all the circuit chips are built. Now the question is how to make this silicon wafer like a thin disc on which all the circuit chips are built. So to make these wafers, we'll use a method known as Czochralski method, which is also known as CZ processing or CZ method. So in this method, we'll use a huge block of pure silicon, which is known as ingot. And to grow this ingot, we'll use a most common method, which is CZ method or Czochralski method. Now let us understand the concept of Czochralski method. We'll understand how this works step by step. If you observe, we are having the pot, which is a quartz crucible with graphite liner. We will take a high purity polycrystalline silicon and put it inside this quartz crucible. It is similar to your cooking pot. Next, we'll provide the heat. So this pot is surrounded by the graphite radar and we heat it up using radio frequency induction, and this get incredibly hot and we maintain the temperature slightly above 1425 degrees centigrade, which is hotter than a volcano. Then we need to protect this silicon. At this high heat, the silicon can get dirty from the air. So we use an inert gas like helium to prevent any contaminations so that we can have 100% pure silicon. Next, we'll take a small piece of perfect crystal, which is known as seed crystal, and we dip this seed inside the super hot molten silicon and very slowly pull it upwards. And as we pull upwards, we also rotate this seed. So, this seed is dipped inside the silicon and slowly it is pulled upwards. At the same time, we'll rotate this seed. As we pull this seed upwards, the molten silicon will stick to it and it cools down to solidifying into a solid crystal. Now, we can control how thick this ingot is by changing two things. First one is the withdrawal rate, which means how fast we pull it up, and second one is rotation speed, which is how fast we spin it while pulling it up. This crystal grows at a speed of 30 millimeter to 180 millimeter per hour. Once this crystal rod grows, we use a diamond tipped blades to slice the ingot, which will be around 0.25 mm to 1 mm thick. So once the crystal is grown, you'll use the diamond tipped blade to slice this ingot into a very thin wafers. So these thin wafers are known as the silicon wafers. on which the circuits and chips are built. So finally, to summarize the operation, we melt the silicon in quartz crucible at 1425 degrees centigrade. We dip the seed crystal and pull it up while rotating. We get a big ingot which is grown crystal, and we'll use diamond blades to slice this crystal, and finally we'll polish it. I hope the concept is clear to you now. If you have any doubts, please write them in comment section below. Don't forget to like and subscribe for more engineering videos.